Hello everyone and welcome back. So now it's time to try out an example of calculating those internal forces. So let's get to it. So first off, we got a beam right here, and we're going to try to find the internal forces at C. Now remember, we're going to use the method of sections to do this. Before we can do that, we should calculate our external forces. As a note, since it's a method of sections, we only really have to calculate the external forces for the section that we choose. Considering that this looks kind of crazy, I'm probably going to just choose this side. So all I need to find is the external forces right here, the support reactions right there at B. So I've given you a plan. I want you to go off, do amazing things, solve this, and come back. So 3, 2, 1, and you're back. So let's try this out and see how it goes. So first off, we got to get those support reactions at B. It's not too terribly difficult. We have a beam here. I've drawn a free body diagram of it. This 18 kips came from my distributed load because it happens 6 feet, 3 kips per foot, so 3 times 6 is 18 kips. 18 kips. And since it's a rectangular shaped distributed load, since it's the same the entire time, it applies at its midpoint. 6 feet long, so that's 3 feet away from A, which you see right here. Then I have a single support reaction at AY because it's the rolling support, and I have supports or reactions in both the X and Y direction at B since it's a pin support. And this should be enough to solve. So let's think about this. Once again, I don't need to calculate A because I'm going to be cutting right here and only care about the right side. First off, sum of forces in the X direction, Bx is equal to 0. There are no other horizontal forces. By, well, I have a component right here, 18 kips, which is pointing down. And I have a component over here, By, which is also pointing down. And you can see I get that By is 6 kips. Now, here's a point I want to make right now that you need to think about. The sign that I show right here is not because By is pointing down. It's because By is causing a clockwise moment around point A, while this 18 kip force is causing a counterclockwise moment around A. I determined which one was going to be positive at the very beginning. I said counterclockwise is positive, so that this became a negative moment. Do not look at the forces to determine, well, it's going down in the negative direction, so it's a negative. That will mess you up. Just keep both of them positive, even if it's looking negative, and then determine, okay, is this going to be turning it clockwise or counterclockwise? Considering how that was recorded, it might have looked like the opposite. But you know what I mean. You have to think about the way it's turning it, not just the direction of the force itself, or the direction of the position vector itself. So please remember that. Okay. Now with that, we have our support reactions, so we can then go ahead and use the method of sections to start solving. So we cut right here. We only take this part, and because we cut it, we have to add in a shear force, a normal force, and a moment. These are all the internal forces and moments at point C. Now, as might be like, reminding from earlier, well, there are no forces in the X direction, so guess what? That one's going to be 0 as well. No normal force. And that's a pretty common thing. It's not always the case, but you see that quite a bit. Then for our shear force here, well, there's only one other force, and so that means that, for one, we drew it in the wrong direction. It should be going up. And that shear force is going to have a magnitude of 6 kips. And finally, our internal moment. That is caused by this force right here. And so it's 6 times 4.5 feet, which is going to be negative 27 kip foot, with clockwise being considered positive, or 27 kip foot counterclockwise. Now, as a note, if this had been 3 rather than 4.5, it would have been an 18 kip foot a moment. If it had been 2, it would have been a 12 kip foot moment. And all the way down to 0, it would have been a 0 kip foot moment. So the internal moment increases as we go away from this force. That's very important for solid mechanics. Less important for here right now. Just if you calculate it at several points in the same beam and you see like the moment keeps on changing, that's expected. So don't worry about it. So with this, I hope it helps you. We're going to try out a few more group problems, and then we'll go onward to new and interesting things. I'll talk to you later. Bye-bye.